Hello everyone and welcome. My name is Julian and I'm a product manager for TwinCAT automation software in the area of connectivity and IoT. In this webinar, I'll talk to you about how OPC UA Companion Specifications can be implemented using the TwinCAT OPC UA Nodeset editor. The goal of this webinar is to bridge the gap between the information model and the running automation system. Over the course of this video, we'll look at semantic interoperability, typical use cases, the product fit, and main features of the editor. I'll also walk through a practical demo from importing a Nodeset to the PLC integration, including client validation with data access and runtime method calls. So with that, let's get started. From model to runtime. Implementing OPC UA Companion Specifications using the TwinCAT OPC UA Nodeset editor. If during the webinar you have questions, please use the questions window and we will answer as many questions as possible at the end of the webinar. So, I'm going to start with a quick introduction to semantic interoperability, followed by a brief product overview and a positioning within the TwinCAT ecosystem. I'm going to present relevant use cases, showcase the main feature highlights, and as mentioned before, show you a demonstration, a walkthrough, and last but not least, some further information for you about this topic. So, introduction. Levels of interoperability. What is interoperability and what does it have to do with OPC UA? Well, there's 4 kinds of interoperability that are built up on each other. There's the foundational interoperability, physical connectivity, which means you can transfer data from one system to another without interpretation, that is. Then on top of that, we have the structural interoperability, or also called syntactic interoperability, which allows the identification and extraction of individual information and data structures for further processing from the entirety of the transmitted data. For example, one element in the XML or JSON, because thanks to the tags, you know what is what. Then, building on top of that, we have semantic interoperability, which is also what we're going to focus on today. It allows for the correct semantic interpretation of individual information. And last but not least, organizational interoperability, which allows for efficient organization of interacting processes. We're not going to look at that. We're going to focus on this. Because semantic interoperability is what we're trying to achieve when using OPC UA with companion specifications. So, what is that? Semantic interoperability means that different systems can exchange data with the same machine understandable meaning, allowing a client to auto-discover, read and act on the data without vendor-specific knowledge. In OPC UA, this is achieved by using standardized information models, for example, companion specifications, there's others, and they standardize the following things, and not just the transport. This is a lot of words. I'm going to show you what that means in pictures. So imagine we have 3 machines, each with a different controller. One has a Beckhoff controller and the other 2 have any third-party controller. And they all have information about their status, their machine mode. The Beckhoff machine may present it like this, under the PLC1 object in a folder called main, as the main program is called, and then down there you have the information. On the second machine, we may have a folder with some variables in it, and on the third machine, we may not even have an organizing folder, just some variables and an object on the directly under objects, and some more complex configuration beneath the machine operation mode object. Looking at the S machine mode from Beckhoff and the mode of operation from the second machine, and the mode of operation from the third machine, they look all very different from a client's perspective. which presents it with interoperability challenges. The hierarchy is different, getting from the entry point objects to the concrete node that we want. The names are different. The types are different, string, enumeration, and even a object. Then we have different semantics with the two highlighted variables, meaning the opposite when having the value true. And even different features in this case, with the Beckhoff machine being able to toggle sleep mode while the others two cannot. And there's even more, different references, units, states, etc. And take this all together, and the client is presented with major interoperability challenges. And that's where companion specifications come in. Because, as mentioned before, companion specification standardize those things. A companion specification usually consists of a Nodeset file, which is the machine-readable XML file, and other normative files like PDF documents that explain what the types mean, how they should be used, and in general how the specification is to be interpreted. And by using the machine-readable XML and giving it to the client and the machines, auto-magically it all just works. Well, it's not quite like that, but to get that result, that's why you're here. And to sum this all up, an OPC UA companion specification defines a domain's information model and its semantics, with domain in industry is meant, for example, the wind industry or the packaging industry. And a Nodeset is the importable, machine-readable XML file that implements that model. And basically, load the Nodeset to get those exact types and nodes in your server. That's what I want you to take away from this introduction. So, how do you do that? How do you get the file to animate there and make everything look all right? Well, at Beckhoff, you use the TwinCAT OPC UA Nodeset editor. Its product purpose is the import of OPC UA Nodesets into TwinCAT. It works together with the TwinCAT OPC UA server. And as you can see on the right, it allows you not just to import core specifications or companion specifications. That's what I meant earlier by saying companion specifications are one way to standardize this. On top of companion specifications, there can also be vendor-specific models from individual manufacturers, for example, that have their own data types. That can still be standardized, but then it's not a companion specification anymore. So, who's the target audience for this? Machine builders, for example, that want to fulfill companion specification requirements, like PackML for packaging. Also, end customers that require their suppliers to implement their vendor-specific model. For example, some large automotive companies want their suppliers to make the machine present its information in a way that they want. And while this is a graphical manual tool as of now, in the future, it will also support automatic code generation to simplify the engineering, but we'll get into that later. It's a chargeable TwinCAT 3 engineering tool, and it looks like this. The user interface is divided into different areas. It's dockable, so you can adjust what it looks like. And short summary, the left side is all about types. The center is about editing your project, attributes, nodes. And the right side is all about your machine. Basically your project overview and the information that's in your machine. Left's like the library. Under 1, you find the menu. 2 has the type explorer, which lets you browse through the types that you have loaded with the nodesets that are currently available. Then under 3, you have the models view, which shows you the models that are contained in the nodesets that you currently have loaded, because one XML file can, in theory, contain multiple information models. Then under 4, you have the message viewer, which is the log of the application and what you are doing. 5 is the node editor. It allows you to edit nodes and the attributes. 6 is the TwinCAT target browser, which allows you to connect your instances from 7 to the PLC. And 7, well, it has the instances, the objects, the variables, and so on. This is a different layout, what it could look like. Here on the left side, you see a data type, an enumeration data type that's currently opened, and you can see the different values. And you can see in the models that we have now loaded a lot more than just one Nodeset and model. But the middle is differently arranged, but still the same with the node editor and the target browser. And on the right, you see a little bit more complex project structure. So that's the Nodeset editor. Where does it fit into the TwinCAT ecosystem? I have to start with a quick introduction to PC-based control because it will be important later. In more traditional architectures for automation, different devices had different tasks. For example, there was a dedicated PLC controller, maybe a motion controller, and maybe a connectivity gateway to connect two machines to one another. With Beckhoff, you have PC-based control ever since 1986. And PC-based control replaces this multiple dedicated automation device thing with one software-centric PC-driven control platform. We call that platform the software platform TwinCAT, and TwinCAT is a modular software that can be extended with so-called TwinCAT functions. Functions are arranged in different areas, connectivity being one of them, with the support for over 40 different protocols. And this is different presentation of what it can look like. We have system functions, HMI functions, measurement, and so on. And the Nodeset editor falls in the connectivity area, and so does the TwinCAT OPC UA server. We also split TwinCAT up from an understanding standpoint into the TwinCAT engineering and the TwinCAT runtime. The TwinCAT engineering is probably an engineering laptop that is used to program and configure the machine, and the runtime is usually the industrial PC that is in the control cabinet. But it could be one device if you decide to install your engineering on the industrial PC, or you use the runtime on your local laptop to test implementations beforehand. So connectivity has configuration and communication, as do the other products. And in the area of connectivity, next to OPC UA and other IoT functionality, for example, there is the Nodeset editor at home. Thanks to the aforementioned PC-based control and TwinCAT's ability to run on PCs, TwinCAT OPC UA runs on all industrial PCs except the very small CX7000 series from Beckhoff. And you can install it on the low-cost design industrial PCs up to the many-core design industrial PCs and get the same OPC UA just with more or less amount of nodes, performance, and so on. So now we know how it works technically, where you can use it. So when do you want to use it? And that's where we get into the use cases. TwinCAT and TwinCAT OPC UA, this is my statement, is they are enabled for every use case. Because, as I mentioned before, we have been doing PC-based control for over 40 years now. This usually looked something like this. New Beckhoff controller of TwinCAT 3 or TwinCAT 2 back then. It had Windows installed and maybe the PLC client server and PubSub on it. But because PC-based control is our vision, and we believe a PC can do anything, instead of a dedicated machinery or pack-ML gateway or controller, we aim to provide a one-fits-all. That means industries and domains, PC-based solution. So this is one of them. Could be the Windows install with a PLC server client all on one device. But it could also be a new Beckhoff controller that runs TwinCAT 3 for Linux, with Linux as the base operating system. On here, you could have the PLC and client running natively on Linux and have the TwinCAT OPC UA server or the OPC UA PubSub functionality running in containers on top of a container runtime. You could also still have existing TwinCAT 2 hardware from many years ago that has PLC and client server already installed based on Windows, but you might want to adjust the way information is presented, or you have higher security requirements. That's where you could use a new Beckhoff controller and use it as an edge device for example, in this case, also running Linux, and then getting information from the TwinCAT 3 controller with Windows, the TwinCAT 2 controller with Windows, and presenting it to the cloud, which could be your MES, your ERP, and so on system, as a gateway edge device. But if that isn't flexible enough for you, you can also go into a data center with TwinCAT 3 for Linux and run the same applications that I mentioned before on top of a container runtime on Linux in a virtualized environment. And this is everything that can be configured using the TwinCAT OPC UA Nodeset editor. Basically, any relatively recent Beckhoff controller that can run TwinCAT 3 and where the OPC UA server can be installed, you can export and in the future also generate code for. So let's look at the workflow on how that is done. This is the Nodeset editor, and we're going to start by importing the models that we want to work with. They can be from companion specifications, core specifications, or vendor-specific models. They could also be what another third-party modeler exported, because you may want to model types, which is something the Nodeset editor cannot do yet. And for that, there are great other tools available. And then you can import them into the Nodeset editor thanks to the standardized format. After you've done this, you would create instances to represent your machine and what you want to model. And from here on out, we are going to differentiate between the PLC first workflow and the OPC UA first workflow. As the name says, with the PLC first workflow, the PLC already exists, or you create it prior to mapping OPC UA and that PLC. You would use the TwinCAT target browser for this to create that connection. Once you're done modeling and mapping, you would export your configuration to the TwinCAT OPC UA server, and the server and the PLC will exchange data based on those manual mappings. The alternative is the OPC UA first workflow, where you model and then you can create new PLC code and the required PLC libraries using the integrated code generation. This could look something like this in the future, where you have the project and the libraries auto-generated. This is then running in the PLC, and once you export your configuration to the server again, the PLC and the OPC UA server will exchange data based on those automatic mappings. These two ways are different, but for now, the OPC UA first workflow is not yet available, and so is the code generation, which is why we're going to focus on the PLC first workflow. But first, a few use cases for when you want to use this. For example, when you want to customize your own namespace without any specification, when you want to make your own standardized namespace using a companion specification like plastics rubber, or if you want to reuse existing node sets with TwinCAT from another modeler. For the OPC UA first workflow in the future, we see use cases like generating a PLC project with instances based on an OPC UA namespace, or generating a PLC library for the types based on OPC UA namespaces to work with them in your PLC. So much about the workflow. What can the editor actually do? Well, it can instantiate objects and variables from object types and data types using drag and drop. It can create scalar, array, and matrix variables for simple unstructured data types. It can use the TwinCAT Nodeset TwinCAT target browser to create TwinCAT mappings for the variables and methods, also using drag and drop. And this allows you to decouple the PLC project structure from the OPC UA representation. The mapping can be done online using ADS or offline using the TMC file that comes out of your TwinCAT project. And you can also do the mapping to multiple ADS devices in one node set, meaning you could acquire from multiple PLCs into one OPC UA server. Then we have a lot of usability features, like deploying to the OPC UA server automatically, locally, and remote, using ADS. Also, the TwinCAT OPC UA Nodeset editor install contains a TwinCAT 3 OPC UA library that contains frequently used types. The editor, as you can see on the right, has a search, filter, and highlight functionality, allowing you to browse quickly through the available types and instances in your project. And it supports the validation of node sets and mappings. Also, people who already work with TwinCAT will have noticed that it has a familiar user design, including dark mode for those who care about that, which is me, for example. And it looks similar to Microsoft Visual Studio, which is our TwinCAT engineering environment. So, in the future, it will allow for TwinCAT code generation for types, returning a TwinCAT library, and also code generation for instances, returning a TwinCAT project. But the stuff I mentioned before, that is available right now. And this is compatible thanks to the standardized format with other tools as well, meaning you can import from them and also export to them if the editor is not the last tool in the chain. And the engineering being restricted to Windows and either on hardware or in a virtual machine. While this is the engineering, the runtime can run on Linux, TwinCAT BSD, or Windows, either directly on hardware in a virtual machine or in a container. So you're really not limited with the use case. And this is everything about the feature from the OPC UA Nodeset editor and where we go to the demonstration. So this is the TwinCAT 3 OPC UA Nodeset editor. It currently has loaded the My Woodworking Machine project. And this is the end state of what I want to show you in this walkthrough. We have machine A and machine B. They both have identical structure, just with different information. How can we validate that? We are using the UA client, UA expert. And here we see the namespace from our TwinCAT OPC UA server. And just as an example for the identical structure, I chose the identification asset ID and device class. And you see both have the same name, same string, same location, same hierarchy, and so on. Just the value changes. And that is because we actually do have two different PLCs running. We have machine A, which is a My Woodworking machine. It has a My Machine object in the global variable list with the identification information and so on. And it has in the main program a variable telling whether it's initialized and a structure of the AMS net ID of this machine. And the second machine is quite different because it's just our TwinCAT OPC UA server mapping sample for use with the Nodeset editor, where there's all kinds of variables that change values and also some that don't. And we're going to force this generic structure into our, companion specification representation. So, to achieve this, we're going to start where I started earlier. We're going to first load that project just for machine A and see that machine B vanishes. We now just have machine A and also some fewer models. We have namespace 1, which is our My Woodworking Machine project node set where the machine A is located and its nodes. And we have the namespace 5, which is my vendor-specific woodworking machine, which is the type that defines machine A based on machinery, woodworking, and so on. And in here, we're going to extend the manufacturer-specific folder with some information of our own. First, if you remember, there's a B-initialize variable, so we're going to add a bool. We can do this by searching for it, dragging and dropping onto the manufacturer-specific folder. And now that we have this instance of bool, I would like to connect it to the PLC. So we go to Tools and Target Browser. And I can now see that we have user mode runtime machine A and user mode runtime machine B. Machine A is what we're looking at. And under main, we have the B initialized variable I showed you before. And by just dragging this and dropping this onto instance of Boolean, we have now successfully mapped it. We could have also done this using the TMC tab, where we have access to the TwinCAT project and its TMC file. And in there, you also have the B initialized. It's the same TMC file twice. And but we're not going to do that because we do have access to the live PLCs, which is why we're going to use them. So now we have this bool, and I'm going to rename it to machine is initialized and save this. And we also had some other information, which is the AMS net ID of the machine. We don't currently have the AMS net ID type, which is why we are going to load it from our sample types Nodeset. By right-clicking and filtering for this namespace, we can check whether this Nodeset contains our AMS address. It does. If we have larger node sets and we don't always want to look at the entire thing, we could have also just looked for AMS A, and we would have found AMS address and its members. So that's the type we want to use, but instead of boringly dragging and dropping the node the same way we did before with the Boolean, we can also take advantage of a convenience feature by dragging and dropping this variable and holding Shift. While we do so, we can drop this, and now an instance of that type has been created because the PLC knows what type it is, and we can now rename this to AMS net ID of machine. We can save this. Now we have added a simple variable and a structured variable, and we can now deploy this via ADS, giving it the local AMS net ID of our OPC UA server, saying that we would like to restart it after upload and create a backup of the current remote configuration for the node sets. We're going to press OK. The node sets and models are being exported, and they're being transferred to that host, which is this client. That's a host this client is connected to. It went gray for a second. That meant that the server has restarted. And when we rebrowse the root node, we will now also see that under machines, machine B has vanished and we only see machine A. It still has the same identification and so on, but under manufacturer specific, it now has AMS net ID of machine, and machine is initialized as well. And we can drag and drop this and see the values. Now, in the presentation earlier, I talked about the mode of the machine. And there's a method here to set that mode. Why do we need that method? Because in the machine overview, the current mode variable, while we can read it and see that it's currently in semi-automatic mode, we can't actually change this into sleep mode because the variable is only access level current read, meaning it is read only. So instead, we want to call this this set machine mode method. Looking at the Nodeset editor again, this method is here already, and it's already mapped as well. It's the same workflow, going to the target browser and then going to the machine, taking that function block that represents this job method and dragging and dropping it. I'm not going to do that because I already did that. I could do it, it just overrides the mapping. And because I already did that, we can go back to the UA client and now call this method. It's currently in semi-automatic and we want it to sleep. So I'm going to call, and it takes about 4 seconds because I have a timer in there. And green means the method call succeeded. I'm going to close this. The current mode has been set to sleep because that's what the method does. It just sets that variable and returns set value. And now we have machine A configured to our liking. But now we want to add the second machine, right? And how I would usually do this, and that's also what I actually did do, is I would see what type is my machine. I can double click this, copy this value and add it into the search bar, look for it and see that we have the My Woodworking Machine type. I can drag and drop this onto our machines folder and see that we now have the instance of My Woodworking Machine type, including that setMachine mode method. I would rename this to machine B, save, and see that we now have them both here. But the difference now is, while from machine A, all the variables are already mapped because I did that off camera, nothing is mapped for machine B. And because it would take too long to do all this, I have already prepared a project where I have done that. So I'm going to load that project. I don't want to save my changes, no. And this is the A plus B project, where I have already done this. So current project is closed, new project is opened, and we can see machine A and B are still there, but now it is mapped, including the method. So I'm going to deploy this configuration again, go back to our UA client, and as you can read down here, the editor is still deploying via ADS, but now it's done. It's going to restart the OPC UA server, as we will see by a faint flashing. We can reload and see that machine B is there again. And we can now take the same variables as before, for example, asset ID, or maybe, let's just take all of them. And we can see it's the same display name, the same data type, and so on, just the values, because it's a sample project, they are static in this case and sometimes a little bit dynamic. And this sums it up. We now have machine A and machine B, which have completely different structures within the PLC. The one having a main and one global variable list, the other one having many, many variables and a lot more extensive structure. But from the perspective of the OPC UA client, they look the same. And this is what we wanted to achieve. So let's get back to the presentation. Well, further information. I teased this in the advertisement for this webinar, and yet now I'm going to show it to you. The TwinCAT OPC UA Nodeset Editor Co-Agent Integration Prototype. For those of you who have not heard about the TwinCAT Co-Agent, it is our intelligent assistant for working in the engineering, but also during operations, during runtime, that can help you all around TwinCAT. And the TwinCAT Nodeset Editor Co-Agent integration basically means that within the Nodeset Editor, you can see this in the center left, you have a co-agent chat window with which you can communicate, that can not just give text back to you, but that can also interact with the UI of the Nodeset Editor and the nodesets that you're working with. So what you can see here is the chat window and the types and instances, and we're now going to focus on the most important. In the center, we have a summary of what the co-agent did, and it says that it built some data types. You can see those on the left, the ST axes, the E machine state, and the ST machine. And on the right side, you can see the instances that have been created from those types, machine 1 and machine 2. And they have been mapped to their PLC counterparts. You can also see the steps performed, and this is a nice screenshot for those of you who've already worked with bots, with large language models and agents. And we're now going to look at what came next, because I thought I want to do something kind of live for you. So I'm thanking the nice Claude Opus 4.8 model for doing the work. And I'm asking it to add a number of nodes to say hi, to greet you, the viewers of this webinar. And I did not instruct it before telling it what exactly it should do. I'm just writing, please add the things. and it's calling tools to understand the state of the editor, and it's running a builder script to add those nodes. It's asking for permissions on tools that I haven't used before, and it's now summarizing what it did, and it added those greeting nodes. We can see that here in the welcome message object with a full greeting string variable, and the value of that string variable is hello and welcome to the webinar. Enjoy the show. You've already enjoyed most of the show, but there's still some further information to go. This is not released yet. It is a prototype, but I just want to show you that we are working with the latest and greatest, and it can be also used within OPC UA to make complex tasks a little more easy, and maybe even have a companion while working with OPC UA that helps you understand certain aspects of it. So, if you want to get the Nodeset editor, how do you do that? Well, I said it before, it's a licensed TwinCAT product. It has the TE 6100 base license, L1. It's always required to use the product, and it allows the stuff I showed before. And there's an optional add-on license, the TE 6101, which is L2, and it's the license that's required for the automatic PLC code generation. I said before, same as the co-agent integration, PLC code generation is not available yet, but once it is, you can optionally buy this license to get that, the PLC code generation. And last but not least, we have the 7-day trial license, which you can install and use to do all the stuff from L1 without being able to save or export. And we recommend buying any of those licenses in combination with a dongle. So, some OPC UA FAQ at the end. Where do I actually get node sets and normative files from? Well, the editor helps you with that. It has a help window under which you can find the OPC UA Nodeset repository. And when you click on that, it will open the GitHub page and showing you where to download, for example, PackML for packaging, including all the companion specifications and core specifications version history, should you require a specific version. This is the XML, the machine-readable part, and where do I get the human-readable part from, and maybe other normative files. Also from the help window, there's a link to the online reference from the OPC Foundation, and when you click on that, it will open that page. It looks a little bit different now, but the functionality is still the same, and you can download the specification in different formats, and I downloaded it as a PDF for my local storage. So that's where you get those files from. And I'm assuming most of you already know this, but for those who don't, I've been talking about nodes a lot. And if you don't know what a node is, this is a short summary. The node is a modeling tool and a concept basically that is used all over the OPC UA information modeling. A node has attributes and references. And with those references, it can build relationships to other nodes. And by using nodes, the entire information model can be constructed. There's different kinds of nodes. You have instances and types, and they are even split up more into those 8 node classes. First, you have the UA variable, which holds data values or states at runtime. Then you have the UA method, which represents executable functions or processes. Then you have the UA object, which represents entities or systems. And the last instance is the UA view. It provides a filtered perspective of the address space of the server you're looking at, for example. Then under the types, first of all, you have the UA data type. This specifies the structure and constraints of data. The UA variable type is a template for variables, including their data type and allowed values. Then you have the UA object type, which is the template for objects, including variables, methods, and references. And last but not least, you have the UA reference type, which describes the properties of the relationship between 2 nodes. This is what it would look like in the real world, basically. In the Nodeset editor, we use the shown icons. And in the XML, you see on the right, that is where those nodes are written down, what they look like within a Nodeset. And the exact examples we see here construct the namespace we see on the right. And to show you this example in the old visualization, the machine status information node is an object. That's why the folder icon is shown, because it's derived from the object type folder type. And it has attributes, as you can see in the XML, and it has references. Especially, it has an organizers reference that is forward to the target node is enabled. And this builds the hierarchy you see in that screenshot. So, that's it. Do you have any questions for me? Then please use the questions window and I will try to answer as many as possible for now. If you think of a question later, contact us later. If you have any ideas for future webinar content, please feel free to suggest topics. And also be aware that you can always look at this webinar later by going to our website. So, here's some contact information. Thank you very much